Okay, welcome everybody. Thank you for joining us on hopefully your last day of the week, ready for the Easter break. We've got a really good response to this webcast, so hopefully it's one of many to come. My name is Jack Strongytharm. You may have had an email from me, hopefully, to invite you to this event, or you've seen us on social media and the usual places. I'm one of the account managers here at FARO. I look after part of the territory. We'll cover that in a second. Also online is my good friend Christopher Palmer, who's maybe press one slide, Chris, so we can see our folks. So it's the UK, based around the topic of BIM, architecture, engineering, construction companies that we support, scanning and software to consume that content. May see us at other events, obviously in person. So just so you've got some mug shots there to understand us. We do have a good large contingent from outside of the UK on this webcast. So welcome everybody. Hopefully you can understand the Northern English language, because myself and Chris do have a distinction as well enough. Okay, so before we crack into the webcast, if you've been on webinars before, they're always going to hit you with a poll. So here's the first one. So get interactive through these polls. Just press the button that suits you, just to get some interaction from you. Just see who has signed in, because we can't read all the names that quickly. Okay, a huge contingent from construction and architecture, so that's good. Just let it go for a couple of moments while you remember to put your sandwich down, maybe your coffee. Hopefully having a lunch while you're watching this. So 2 more seconds. Architecture's taking over. Very good. So ending in 3, 2, 1. Okay, close that one. So we're fairly new to this system that we're using today. So architecture is the proud winner of the poll, and we got a good continuing civil engineering construction there, doing very well. Okay, last one here, simple one. Like, we use point clouds every day at FARO because that's what we do, but maybe you guys don't. So maybe you're just here to understand about how a point cloud could be used within Revit, or you're already using point clouds in anger, and maybe this software will help you out and do it a little bit better and quicker. So lots of people using point clouds, that's good, but about a quarter of you not using point clouds. So it's good to have you on board as well, get you some understanding. Okay, ending in 3, 2, 1. Okay, right. Well, thank you very much for a bit of interaction there. I'm now going to hand over to my good friend, Mr. Chris Palmer, based up in the Northeast, who's through PointSense for Revit, and hopefully you enjoy. Okay, off you go, Chris.
Okay, guys. Thank you very much, everybody, for dialing in. So, hopefully you can see on your screen there, we've got a bit of a contents page just about the things we're going to run through today. So I'm just going to give you a quick introduction to the PointSense products that we've got, because there is a suite of products available. We're then going to run through some of the wall fitting and analysis tools in PointSense for Revit, and obviously you can see on the screen there we've got some different things. So family creation and component insertion, fitting the pipework and placing pipe fittings, and we're also going to run through some of the latest features of PointSense for Revit 18.5, which is our most recent release currently. I say currently. But yeah, we're going to run through some of those things now. So just to give you a little bit of an idea, PointSense was a product that FARO kind of acquired. We acquired a company called Qubit maybe around 3 years ago. and we develop those softwares a little bit further, and they are the products that we have on sale today. So we have PointSense for AutoCAD, which is just to help you draw either line work or 2D line work, get plans from your point cloud in a much easier way. PointSense Building. We also have PointSense Plant, which is aimed specifically at heavy industry, so oil and gas, petrochemical sites, specifically working over the top of Plant 3D. And we also then have PointSense for Revit, which is what we're going to specifically look at today for people who want to create as-built BIM models, I guess you could say, or as-built BIM, or just 3D sort of 3D models generally. And we also coming with that is a product called VirtuSurv, which will also come with that, all of those installations, which allows us to use the scan view of the scanner to do things like insert windows and doors and take coordinates, etc., etc. So, like I say, we're currently on release 18.5. We normally have 2 releases a year. We'll have a compatibility release to go with the latest Autodesk release. So I guess 19 will be coming up soon. We would then shortly after that have a 19.0 release, and then we will also have a 0.5 release, which is where we generally add new features into the products. Just to give you a bit of an overview very quickly about those products there, so you can see some of the different things that can be done. Again, so looking at PointSense Plant there, that's piping and structural extraction, tank analysis, tie-in points, very specific workflows for that industry. So that's what we've tried to do, kind of break this up into different sort of applications, really. And for maybe larger organizations or people who are looking to use all of the products but save a bit of money, you can go for a PointSense Suite, which obviously enables you to have all of those products under one banner. So let's look a little bit at PointSense for Revit. So like I say, we're currently on release 18.5. In terms of compatibility, this is working with all 64-bit variants of Windows, so it's 64-bit, and we can support versions of Revit back to 2015. Okay, as long as it's all working in 64-bit, no problem. And it will work over the top of any version of Revit or the or sort of like the full version. And we will support recap point clouds. So obviously with Revit having the recap support for RCS, RCP, we are working directly over the top of Revit as a sort of ribbon, and so we're working with that format. Okay, so what can Revit not do with point clouds? So because there are some sort of limitations in terms of what Revit can do with point clouds, these are the sort of the gaps that PointSense is specifically trying to bridge. Okay, so no real 3D point snapping, no scan view available like we'll see in VirtuSurv. Specifically things like no point cloud support for the family editor when you might want to create bespoke components, and specifically then no automatic object recognition. So things like walls, pipes, steel, these are the main sort of components of PointSense for Revit, which we are trying to improve the capability of Revit to deal with point cloud specifically. We also have some good model comparison which we're going to look at as well. So that's the kind of emphasis behind the product. Obviously with FARO acquiring Qubit back a few years ago, we noticed obviously that the scanning time and the use of scanners had got to the point where it was very quick and people were very comfortable with that process, but there was a sort of back-end lag in being able to get some kind of geometric model, CAD, BIM, whatever it may be, from the point cloud. So that's the kind of gap we're trying to fill with these products specifically. So just looking at the features, a sort of overview of the ribbon that we're going to look at in a little bit. We're going to do some live demoing shortly, so it won't all be PowerPoint today, guys. Don't worry about that. But you can see in front of you now, we've got this PointSense for Revit ribbon, and just an idea of what's on the ribbon. So to the left-hand side, we have the object tools, which includes the fit wall, fit pipe, place pipe fitting, fit structural element, those type of commands. We also have some alignment tools which go specifically hand in hand with those object tools to enable us to actually join all of the walls together, all of the pipes or the elements, structural elements, but within a sort of user-defined tolerance or orthogonal, if that's what we want to do. And then moving over to the right hand side there, we have sort of things like our surface analysis tools to allow us to check the accuracy of our model, and some good tools for dealing with coordinates, large coordinates. If anybody deals with large survey coordinates, everybody knows Revit can struggle with the large coordinates of point clouds at times. So we have got some tools to try and overcome that. And to the right hand side, you'll see the VirtuSurv tools. Now the VirtuSurv tools are what we'll probably look at that a little bit as well. These are kind of the original tools within the product that have kind of been superseded, but also kept in there to allow us to send specific commands through from the 2D photo type views from the scanner. Okay, so the first thing we're going to look at is the wall fitting tools and the align walls and the surface analysis. So in the most recent version of PointSense, we have added a slight new feature. Now, the Prepare Point Cloud tool has been available in the software for a while, and what this does is it's essentially like it's called a tomograph, or like an X-ray type view that we create of the point cloud to enable us to see much more clearly the outline of the walls, the windows, the doors. So it's looking for essentially the strongest resistance in the Z plane. And giving us a nice strong line based on that resistance. So you can imagine things like little bits of noise that might hang off the side of the wall, or different elements like that get ignored by this prepare tool, and that gives us a nice clean basis with which to fit our walls. Okay, so and what we've added in the newest version is this contrast factor. We did have a few comments from people where they were using large floor plans. They would get contrasting issues with the large floor plans. So we've added this contrast factor in now, so we can change that dynamically as we create this prepared point cloud view. But once we've created that view, what we then have is this wall fitting tool, and this allows us to literally click 2 points on that prepared view, and that will measure the thickness of the wall, detect that thickness, and then will suggest to us the closest matching type that we're going to use. Okay, we can then either use the suggested type, or we can use a different type, and we can insert that type with an adjustment so it will actually fit that to the actual measurement itself. Okay, we're going to do this live in a minute, guys, anyway, so not too much to worry about that. Now, one thing we did also try to do is break down the process of modeling this building of this building, because one thing obviously people will know who use Revit, sometimes Revit can have sort of problematic issues with wall joins if we've got slightly angled walls and things like that. So we've kind of broke the process down into a fit wall command, so we can fit as many walls as we want, and then we can do a batch join of those walls based on our own user-defined preferences. So like I say, if somebody wants nice 90-degree angles, we can force it to nice 90-degree angles, or if we want to stick with the best possible wall joins we can get, which are sort of matching the real world conditions, then we can do that as well. Okay. Once we've done that, what we can do, we can take an analysis of that surface and actually perform or provide a sort of heat map with a legend to tell us how accurately we've modeled that point cloud. Now, it's interesting when we do things like this with existing conditions or existing buildings, because existing buildings are very rarely straight in terms of the verticality of the wall or the along the length of the wall. So we can get some interesting results, and obviously you can see there we can export that as a text file if we want to, or we can put that onto sheet views to show us the results and provide that to a customer if we wanted to give them confidence about how well we've modeled that point cloud. In version 18, we did add support of the USIBD standard, which you can see there's a hyperlink on there, which we're also going to provide these slides afterwards, guys, for anybody who wants them. But we can actually now do an analysis based on that standard and provide a level of accuracy sort of report, if you will, or a heat map with a legend, which we can then put onto a sheet. So there is ways to do that as well. So what I'm going to do now, guys, I'm just going to go and press the escape key on this PowerPoint. I'm going to dive out of here, and I'm just going to drop into my Revit view. Okay, so hopefully on the screen now you should be able to see a point cloud. So if I go now to the top of my screen, we've got this PointSense toolbar in here now. So you can see this is exactly the same toolbar we were just talking about. One of the nice features that we do have is this hide or show point cloud command. I always like to show that because it's one of my favorite tools, just because it's so simple and it's something that's not already in Revit. So we can just hide or show the point cloud at any time. Now, what we're going to do, if we're just going to go and first of all just create a level, In standard Revit, obviously, I would maybe drop a section through this and create maybe a level. But what we can do with the VirtuSurv tools is create a 3D level selection. So in this instance, now I'm just going to go and click the level tool, and I'm actually just going to zoom in, and I'm going to create a level just at maybe just underneath these first floor windows. And what will happen there now, you can see on the left hand side, we have this floor 2 which appears. Okay, now if I double click that, you can see it's cut that slice at that level. Now these VirtuSurv tools actually are the tools that work within the 2D scan views as well, and also in the scene app that we're going to look at also shortly. But if I just first of all go and maybe just show my crop region, just on here now, I'm just going to crop down this view to show you how that prepare point cloud tool works. Okay, we'll just go and crop this down. We don't want to run the full point cloud, and I have done one on the ground floor as well just to show you. But if we just crop down this view, you can see now we obviously have slight little sort of bits of noise around this point cloud, which could make it a little bit more difficult to model. So what I'm going to do, I'm just going to go first of all to this left hand side and run this prepare point cloud tool. Okay. And like I say here, we can choose the pixel resolution. We can choose what we want to do with this view once we've created it, if we want to insert it into a new copied view. And here's the contrast factor that we can also use as well. So if I press start there, it'll just think about that for a few seconds, and then you should start to see a sort of square appear on the screen that is essentially going around that point cloud and analyzing that for essentially best resistance in the Z value. So just like an X-ray image, like an X-ray type of image, you can imagine. And this is creating a sort of tiled raster image. So you can see each one of these squares is going to be a tiled image, but obviously we can lock that tiled image off if we don't want it to give us any problems in terms of selection. But it's just going to be there sitting in the background and allow us to model over the top of it. So you can see obviously the difference in the quality now, specifically at things like windows, where we're removing a lot of the noise, and it's allowing us to see much more clearly these wall faces. So I'm just going to cancel that, guys. Okay, so cancel that. Hopefully it gives you an idea of how that works. Let's just shut that view down. So back into the 3D view, I'm just going to go and make a quick level at the top of this wall. Okay, so we'll just maybe call this wall plate or something like that. Let's just call this one top of wall. Okay, because that's going to be obviously the level we're going to model to. And then what I'm going to do, you can see here I've got ground floor, but I've also got ground floor prepared. So I've prepared this full ground floor view. And if we want to, we can just go and tile those together so we can sort of have a look at the difference. So here's our tiled view, here's our full size prepared view. So what we're going to do is just work with this prepared view on the right hand side. So what I've also done, guys, I've just taken a little bit of the liberty of creating a survey wall type. Now, little bit of a not bone of contention, I wouldn't say, but definitely a preference for some people when they're modeling existing buildings. A lot of people will want to model using a default wall, okay, just because it's a block wall, it's a survey type of wall, and then add that metadata in afterwards. And to be honest with you, my preference, just in terms of speed, is to do that because it means I can quickly get a model and then I can analyze the materials and things afterwards if I want to add those in. Okay, but we can also model with any of these different, obviously, system families if we want to. Just to let people know how that's working. So what I'm going to do now is just go to this PointSense tab and go to the fit wall command. Okay, we're going to choose our top constraint, which is obviously going to be the top of wall, which we've just created, and we can go and press our start wall fitting. You'll notice there's a little button here called fit only one face of wall. So where we do have sections such as underneath this stair cupboard where we've just modeled or just scanned one face of that wall, it doesn't pose us a big problem. We can also fit against that line. But what we do need to do is estimate or know the thickness of that wall, because obviously we can't obviously analyze that because we haven't got the line to analyze. But if we just go now and press start wall fitting, I'll just go and zoom in and just do a few clicks on this here now to just create some wall types. So you can see straight away it's detected that at 400 millimeters, and that's with a rounding factor of 5 mil. Okay, so you can also probably see if we scroll down, we can choose now which layer we're gonna tell the software to adjust when it puts this wall in. So if I go down now, you can see also, sorry, on the left hand side, it's suggested to me that the closest matching family we have is system family is this 440 foundation wall with a 40mm delta. But what I'm going to do is just go down and find my survey wall, okay, and I'm going to insert that with an adjustment. So I'll click that button there. It's put the wall in at the correct angle, in the correct position that I've asked it to, okay? And you can also see what it's done is it's duplicated that wall type and added a suffix after the actual name. So we know that's a 400mm wall. Now, we've got a choice. Because we've inserted that wall, we can now just very quickly run around and model this building up, or at least the outside shell of it. And I think this is really one of the main, or one of the best functions of the software, is the speed with which you can start to now model a shell of a building, because we can just click around the outside. The software is obviously analyzing that and giving us a good accurate reading of the wall types, and we can duplicate that same wall type again and again and adjust it to suit or adjust it to fit. Obviously, if it does already fit, we can change it, or we can reuse it. There's no sort of worry about that. So I'm just going to do a couple more selections here. You've obviously got to use your own intelligence in terms of where those walls change size. So you can see there's a little bit of a step here, and depending how I obviously select this tool now, it is going to obviously either go over the top of that change in thickness, or it will ignore it. So completely dependent on how I do the selection, but you can see we're very quickly building up this sort of outer face of the building. I'll just do a couple more walls, guys, and then I'll just maybe drop one in across the middle, and then we'll just show you how the align walls tool works. So just go and insert that wall there, and maybe one more just here. If you did want to see how the one-sided wall fits, I might just do this little one down here. So if we did want to do that, we can go fit wall, fit only one face of the wall. We probably obviously wouldn't take that one all the way up to the top, but if we just go now and do this one-sided wall fit, now you can see what we've done is we've got the strong line, and the dashed line is obviously our second face. So in this instance, we need to know the thickness of that wall, but we can go and insert that, and it's saying unknown thickness. We can go and insert that selected type, and it's inserted that against that line. So next thing I'm going to do is just go and drop some annotations on here to show us these angular dimensions. So this is exactly as it is in the real world, okay? And the reason I'm doing this is because I'm going to show you that when we join these together, it will be sort of as per the real world, or as per the point cloud, if we choose it to be. So let's go now and go to PointSense again, and we're going to go to the Align Walls tool, and I'm just going to select those walls, okay, and press Finish. Okay, so now what you can see is it snapped all of those to 90 degrees. That's the first option that you have. And in that instance, if we did want to snap it to 90 degrees, okay, then it's telling us how much it's had to move all of those walls to create that 90-degree angle. Now, you can also probably see it's just missed off some of these corners. Now that's down to our search radius, which we can increase and update, and then we'll find those connections at those ends. Now, personally, I don't want to model orthogonally. I want to model to the actual real world. So in that instance, we can change the fittings, or change the settings, sorry, to this leave wall axis unchanged, and update those results. And you can see now all of those original angles that we had are still intact. We have got one wall that won't join here. Now that is just down to the fact that these walls aren't quite properly aligned. You can see there's a bit of an alignment issue there, and it was going to give us quite a poor wall join in that instance. So what I like to do is just maybe go back in and just do that one again. And in this instance, we can actually choose how much we want, how much we will allow what tolerance we will allow the software to change our systems, change our reference direction. So reference direction, see I've got 15 millimeters, and we can also change our maximum rotation. So, and that's going to basically force that wall join together there. Obviously we could go in now and just add those extra joins in. So you can see that hopefully there, guys. If I go back into the 3D view, you can see it's a very quick way of modeling an outline element, or an outline model of a building. It really is speeding up the process. If we just maybe go and hide off, first of all, that point cloud, we can see what we've got. Now, what we will want to do, obviously, is analyze how accurately we've done that. So what I'm going to do now, I'm just going to go and press calculate, and I'm going to go and choose from this selected faces just walls, and I'm just going to go and press select and just choose that wall face and press finish. Okay, we can then choose to do an analysis on that element based on the point cloud, and we've currently got a 50mm grid spacing shown with a maximum search distance of 300mm. So we could maybe even decrease that slightly to 100mm or maybe 150mm, because that's probably a bit too much. But if we leave it at 150 and press calculate, it's just going to take a second to run through that. Okay, just a couple of seconds. And what we will get then is a heat map, and we will have obviously a legend that goes with that. Now, the legend that we have that goes with that can be changed to suit our own personal requirements, and also using these USIBD standards as well. So just let that one finish up there first. Interestingly, you can sometimes see on these on this analysis, this particular building did have some roof spread where the roof was pushing the top of the wall out. So we do sometimes get, on this elevation at least, we do sometimes get some sort of hazing towards the top. But from this now, you can see obviously clearly our windows have given us a big blue error message, error sign, and obviously our fire alarm there's again in the other direction telling us plus 88mm. But generally we're within this green banding. So we've got a nice accurate result there. So what we can do with this legend, if I just go and click that legend, I can go and change the actual style of that. So in this instance, let's say we want to know the level of accuracy range within some tolerances. Press OK to that. And now it's given me a sort of, I'll just change this scale, guys, so you can see that a bit better. Oh, other way. Bit too much. Yeah, you can see it's a bit too close together, but green's obviously 5mm tolerance. Yellow is going to be within 15mm, and obviously anything above that is going to be up to 50 or up to red. So you can see that there now. So yeah, and the other thing we can do is we can edit this to make it bespoke. There's a few different settings in here already. If you just want pass or fail, you can have a pass or fail, and you can actually edit those standards to be your own personal requirements. If it was 25mm that you used, then you can change it in that way. Okay, so to whatever you need. And if we want to put that onto a sheet, we've got this place USIBD legend, and that would then allow us to place that as a family just onto a sheet. Okay, brilliant. So let's just go, and I'm just going to go and delete that there now, bring that point cloud back in, and we'll just quickly jump back onto the slides for 2 seconds, guys, because what I'm going to talk to you about now is a little bit about family creation and component insertion. So what we do have is this bit of software called VirtuSurv. Now, again, this is a separate little bit of software that comes with PointSense for Revit, or all of the PointSense products, and it allows us to just send coordinates through into the software. So specifically for things like putting windows and doors in, this is really, really handy. And the benefit of this bit of software is that it actually will take any file format of any laser scanner. So if you're not using the FARO scanner, it's a shame, but we can take your scans in and we can use them inside this product. So this is why it's a nice tool to have for us. We have now obviously put these tools into Scene. So we're going to look at that a little bit later, but these tools are available within VirtuSurv. And what we can also do is create orthographic images of the point cloud and take those orthographic images into the family templates, and also take 3D selections from the point cloud and push those into a family template. So this is exactly what we're going to look at now. Okay, so let's just jump back out again. Go over here now. So what I'll do, I'll just go onto my desktop, and I'm just going to go and open up VirtuSurv. So VirtuSurv is like I say, the sort of sister tool that comes with this. And you can see now I've got a little map down at the bottom corner. But if I just go and press one of these buttons, this is showing me that this is our site that we're currently working on. Okay, and I've just loaded in the Revit tools down the right hand side. So we have things like level, window, door, these type of things that we're able to send through into Revit. So if I wanted to create some levels from here, I could do that. And also insert some windows and doors. But what I'm going to do as well, I'm just going to go back into Revit and make sure that these are linked. So make sure that this is linked to our VirtuSurv project. And I'm first of all, just to check to be honest with you, the coordinates are correct, I'm going to go and export my scan positions from here and save them on my desktop. Okay, so let's just call that scan locations, save, push that onto the desktop, and then what we can do in here, specifically maybe if we go to the site view, we can go to coordinates and import scan positions. You'll notice we can import positions from our RCP to give us our scanner head locations, but if we do it using this VirtuSurv tool, okay, it's going to give us a small family icon that we can actually hyperlink into a specific view. So you can see there we've got externals 13, 14, all the way around this site, all of the positions that we've scanned from. But if I go and just shut that down, maybe just go and open up one of these family icons and just go to file name and click that hyperlink, that's going to open up that specific view. Okay, so we can now go and start to send coordinates and things through into here. Okay, let's make sure that's linked again. That's okay, it's already linked. So what we should now be able to do, if I go to the 3D view, I mean, these are nice standard window sizes. Okay, we've got some better tools if you've got some more difficult things to model, but in this instance we've got a nice sort of easy, simple repeating window family, and this is where these particular tools come in really handy, because if we load in now the Revit tools and go to our window command, okay, we have a button called create new family type, which we tick, and we can select just a single plain window from the list. It doesn't really matter about the size too much, so we go and select this particular window here. Now what I can do is I should be able to now just go and with 2 diagonal clicks send the position of this window through into Revit. So 2 clicks on there now, Revit flashes at the bottom of my screen. If we just cross over into Revit there now, you can see it's just dropped that window into that position. And it's also, because we had ticked that box that says create new family type, it's actually duplicated the Revit family, but it's actually edited the height and width parameters, but renamed it as well. So we've got a complete new type of that particular family. And if we want to, then we can go and insert some more of those, but we don't always have to then tick create new family type, or we can if they're different. It's completely dependent on what we want to do. But we can then just go and put some of these windows in nice and quickly. So a click at the bottom, a click at the top. Maybe do it from this view here, click there, click there. And if we want to move view, we should be able to do that and go into a different view and then insert that there. Let's jump back into Revit. Hopefully we should then have 4 windows in there. So you can see it's a nice way of placing families from a photographic view and very quickly getting those families in. So we have that for windows. We can also do that for doors. Okay. If you've got something a little bit more bespoke that you want to model, maybe as a Revit family that you want to, I'll just shut VirtuSurv down there. Say we've got these chimneys over here is a nice example I like to use. If we go and cut a section next to those chimneys, obviously if we were modeling this now, we'd have the option, do we want to model this in place, okay, or do we want to maybe create a family type that we can insert multiple times, okay? So what I can do now, we just go to this view. So I'm in a nice sort of 2D section view here. I'm just going to isolate out these chimneys, okay? What I can do, I can use the orthographic image tool to create representations of this, very similar to the prepare point cloud, which can be brought into the family template. So let's just quickly run one of those tools. In fact, I'll go to the 3D view and I'll just orient to that section I've just made. Okay, so we've got that opened up there now. Just drop it against that and we'll just make it a little bit smaller. And then I can actually go to ortho image and we can choose our pixel size and whether or not we want color or x-ray or the sort of clear view, and then we can run that tool there now. So you should start to see, and I need to move the contrast filter to the right hand side, okay, but you should start to see that kind of ghosted image start to appear in there, and that's just to do with the contrast that we've got. But once that's sorted, because it's very important to get the outline of these, specifically for maybe these sort of hexagonal shapes. But once we've done this, we can actually save this to our desktop as like a PNG file with a scale XML file and bring those into any particular family template we want to model. And they'll all be in the right sort of scale. So if we save this now as a family, save this as a file and just call that chimney chimney front. Okay, save that one out. Press OK to that. Okay, and then we can maybe move around to this side here. Do one more. Run those same. I'll push that contrast filter up a little bit further, a little bit more even, and then we can run that side. So you can see we're getting a nice outline of that particular type, and I can save that out as a family again. So we'll save that to the desktop, chimney side. And we'll just do one more, guys, and just one more to show you the top view, and then we can also use this export PC region to take that actual point cloud out into the family template as well. So we'll just run this chimney top, and we'll just go and save that again onto the desktop. There we go. Save as file. Save that on the desktop, chimney top. So now we've got some nice images of that chimney which we can use. And in the 3D view now, we'll just go to look at that view there, and just go export PC region. It's asking us, do we want to save that out as a points file? And we can say obviously yes to that. Chimney points. Save that on the desktop. So now, if I go now to open up a family template, let's just shut this down completely. Go now and open up a family template. We can go and just bring in those sort of references to use. So let's just go and open up a generic model. Press open there. So just looking down at the floor plan now, obviously we're going to bring in the plan view, but if we just look at the top, there's also a PointSense ribbon in here as well. So we've got some options in here, but we're going to use this tool, Insert Ortho Image. I'm going to go and find that XML scale file, chimney top, and open that up and bring that in. Same thing on the side or the front. So on the front we can do that as well. There we go. So we've got that in there, and then obviously go to the left, we can bring that one in. There we are now. So they're obviously, and one thing to note, guys, if we do want to use this, obviously if we're going to move these up to the reference level, we have to move them all in the same manner because they're all scaled against each other. So if we were to go and create a small hexagonal shape on here now, there we are. You can see I'm not the best modeling, but if we just make a shape on there now, just to show that, there we go. Just close off these lines. We can see that that is actually going to be shown within all of the different views. So just quickly close off those lines. So just got one line. Press OK to that. But your line set so small, it's not easy to see where your intersections are. But never mind. There we go. So yeah, within the left-hand view, then we can obviously go and see that, and we can lift that up to the exact height that we want it to be. So we're modeling within that view, and we can obviously model against those templates. Now, if I just go and bring in the points file, okay, PointSense, and we go to Insert PC Region, this chimney points file. Okay, what I can do is I can choose to scale that down a little bit if I want to, in terms of the actual density of it. We go and bring that in as well. Now, this might come in on a slight skew, actually, because of the way I exported it. Yeah, it has done straight away. Obviously, we'd need to go and line that up a little bit carefully, but once we've done that, we should be able to use that as an outline as well. So, as well as we can, back into the 3D view, and then now we've got those points within that family 3D view as well. So you can see that there now. So that's to help us model some of the family elements and things within the Revit project. So just shut those down, and I'm going to go back to our PowerPoint for a minute, guys. We also do have some good tools there now to fit pipes. So anybody who follows Revit closely will know they've now got some good sort of isometric tools and P&ID things that are coming in the software. So that's even more important for us to be able to fit pipe work within the software. So what we have got to allow us to do this easily is some section management tools. So I can crop down the point cloud and save regions of the point cloud and move through slices, which is really handy when you've got a plant type environment. And we've also got some tools for fitting pipework to the point cloud. Obviously very similar outlined there to our fit wall command. And we're going to look at that in a little second now. But obviously once we've done that, we might want to align those or join those all together in the same way we did the align walls tool. Now this is a nice feature because what this allows us to do is actually model small elements of pipes and obviously drop in specific elbows, but then we can use these alignment tools to join things together sort of globally and get a very, very accurate alignment on them. So let's go and have a quick look at those tools. So I'm just going to drop into another file here. This is just an educational establishment up in Teesside. But what I'm going to do then, just navigate around this, zoom in on the point cloud, and the first thing you can see on the left hand side now, I've got my section manager loaded in. So if I go to PointSense now and the define rectangular tool, so we've got define rectangular, define slice, define polygon, define box. A defined box is actually just a clipping box, but it will save that region as a separate section. Okay, but if we use the define rectangular tool and just go and chop the roof off this, okay, we can save this as base of building. It's adding into the section manager this hierarchical kind of breakdown of what we are creating. So within this base of building crop, I can now go and create another crop of the target installation. Okay, so we're constantly cropping down these areas, and then what we can do is we can move backwards and forwards between them without having to sort of hide or show the point cloud or anything like that. We can very quickly get back to something that we want to model. So just looking at this pipe underneath here now, if I go and use a define slice command and just drop that in there now, I can define the size of this slice. So let's say we want a 300 mil slice, or maybe a 250 mil slice. And the X and Y plane, okay, so a horizontal slice, we just go and maybe just do one selection onto that point cloud. What that should do is now, we can call that pipe 1. That should now crop that down to just that slice or just that area of pipework. And if we want to, we can move that up and down. So if I say I want to move that up by 50 mil, I can move it up, okay, to get as much of the pipe in as I want, or obviously back down again to get rid of some of this steel work and give us something to model. So there we go. So what I've done here now as well, guys, is in the object tools, what we've got some batch loading commands. So I've batch loaded all of the MEP fittings, okay, that I've wanted to use. So I've batch loaded before this lots of different elbows and flanges and T's, essentially everything that's MEP related within the UK library. Okay, we've just added that for steelwork as well, which we'll look at, or well, for structural families, we'll look at that as well shortly. And I've also created a carbon steel pipe type here now. So I'm just going to go to the fit pipe command, and I'm just going to go and do 2 clicks on here. What you should see, oh, try that again, just go and zoom in. That was a bad selection on my part. Let's just go and do that fit pipe. So 1 click here, and then 1 click at this end. So what we should get up now is obviously the same dialog box that we had before. Again, I apologize. I need to change my scale and turn that to fine. That was my fault. Fit pipe, go and do that again. It's going to analyze the pipe the same way it analyzes the walls and just give us a suggestion of what is the closest matching pipe size that we have within our library. In this instance, I'm going to go with the carbon steel. Okay, so we've got a delta of 11, but we're going to go and insert that because we don't want to maybe be adding different pipe types within here as we would with walls. But if we've got insulation on this as well, we can add insulation, and you can see it's sticking to the outside size, but then pushing it down to the next matching pipe size. So we can do that insulation, add insulation in that way. So we go and insert that one pipe there. Let's go and insert another pipe. Again, we can run this command as a kind of similar to the wall command, where we just quickly nip around and pick everything up. But just using 2 clicks on the pipe, we're just going to go and use that same pipe we did before. Okay, and now what we can do is go and hide off that point cloud so we can see those. I can maybe change this just to shaded so we can see that, and we can go and place a pipe fitting. So if we go and do 1 click on the end of here and then 1 click on the end of here, we can then go and add a particular type of fit into those to join those together. And if we do want to do that similar to the slide I showed there, where we just fit it to one end of a pipe, we can do that and fit that to one end of a pipe. We can add a pipe link between those, that elbow and that pipe, and then use the align pipes tool to actually do that join. I'm not going to show that today, guys, because we won't have time, but what I can do is, if anyone wants to see that, it's on my YouTube channel, and also I can show you in any on-site demos or anything we do. You can see that's a nice way of fitting pipes and fitting elbows and things to the point cloud. So let's just shut that one down as well. I'm just going to jump back into the slides. Now, if we just open this one up, we do have some new features within PointSense 18.5, particularly the SendToRevit app, the batch loading of structural elements, and also the fitting of structural elements and the alignment of structural elements. So let's have a quick look at these now. The SendToRevit app, you can download this from the App Store, or you can get this as part of your installation of PointSense for Revit or PointSense Suite. It will be installed with that. And it is basically, it's only going to work if we do have, if you have got either a trial license or a full purchase license of PointSense for Revit. But what that's going to allow us to do is use those VirtuSurv tools directly within FARO Scene. So we don't have to do an export of that anymore. Okay, so if you are a FARO user and you want to create Revit models quite quickly, you can see here now, I'm just running this one as a video, guys, because I thought open up another bit of software might be a recipe for disaster. So you can see we've got FARO Scene open, and I'm just opening up a 2D view with this SendToRevit app enabled. Anybody who uses Scene will notice to rotate now, we're holding down the Shift key, because our left mouse click is going to be the selection. But what I can do, I can go and select that level tool, 2 clicks here to obviously set a level on the floor and the ceiling. So we've got that floor 2 that's been sent through. We can call that one ground, and you can see that there. It's working exactly the same way I've just showed you with the 3D level command in Revit, but we're doing it from FARO Scene and sending it through. Again, now we can go and create this one as top of wall, and we can also do this within the 3D view now. So using some predefined 3D views just to make it easier to navigate around, I can activate this wall insertion tool, okay, which is not a fit wall, okay, it's just going to insert a wall based on my selections. It's not a fit wall, it's just an insertion tool. So I've enabled a continuous wall. It's block work, 100mm block work with plasterboard. And what I can do in the 3D view now is just move around using those predefined views I've got, and I can insert the wall directly into Revit from FARO Scene. And because we've enabled that continuous wall, effectively what it's doing is it's always joining the wall as we move around rather than just a single wall. So I don't even have to really click near the end of that wall. It will automatically join those walls together. So you can see there now, we just move around here, some clicks around the start and end of this wall. And again, guys, if you did want to use the window and door commands exactly the same way I've just showed you with VirtuSurv, you can do that now from FARO Scene as well in the 2D or the 3D views. So there we are. Just shut that down and navigate around. You can see there's those walls that we've actually inserted from FARO Scene directly into Revit, or more accurately, the coordinates that we've sent through. So I mentioned there before about the structural framing and the structural elements. If we're going to use this tool, we do need to batch load in some structural beams or structural column types to use, and that's going to make it much quicker in terms of our fitting of these tools. But what we can do, we can then go and use our fit tool to choose either a structural frame or a structural column. We can choose our level, and what we can do is then detect the type of beam. Okay, and what it does is it cuts a section in a specific view, and we'll analyze that against whatever families we have loaded in. Okay, similar to this. Now, depending on how well we've cropped that, or whether or not basically how well we've calculated the noise on that as well, we can fit that to that cross section. So I'm going to show that now. But what we can also do is align elements. So if we've got a beam and a column and we want to sort of batch align these, we can, again, similar to our walls, allow a displacement tolerance and a maximum extension, okay, and actually join those up based on the axis of the beams. So it's a very nice way for us to very quickly run through something like a steel frame and create an as-built model of that frame. There we go. So let's just jump back into Revit to show that. Okay, I'm just going to go and open up this Atrium file, the same file we've just looked at for the SendToRevit app. Okay, so if we just maybe navigate around here now, I've got some cross-sectional beams in this area here. So what I'm first of all going to do is just go to Site, and I'm just going to drop a cross-section next to where I want to do my modeling. Okay, might even get that a little bit closer. Do that one again. So let's get a nice cross-section coming across here. And if I open that up there now, you can see, so I've got my beam inserted, and I've also got actually my beam size written on my beam, which is quite handy. This is a college somewhere down in Wales where the students actually studying structural engineering and things, so they've all labelled up all the columns and beams. But what I'm going to do then now is just go to, first of all, my PointSense tab, and like I said, I've loaded in lots of different structural families here already. So what I can now do is go to Fit Structural Element, and I can choose between framing and columns. So in this instance, let's choose framing, and I can choose my base level. Okay, so if I did this more accurately, I might go and choose the particular level to work from. But the most important thing we're going to do here now is detect the type. So this will maybe give you a little bit of food for thought. So I'm finding a nice clean area. Obviously, notice now I've got the roof still within this cropped region, okay, because that will affect the outcome of what I do. But I do 2 clicks on a kind of cleaner area of the point cloud, and it cuts a slice at that point, and it will start to try and fit steelwork against that slice. So you can see there now, it's obviously not managing to do that in the first instance because we have all of these noisy elements which we can go in and rub out. So because we haven't cropped this specifically, we can't fit that perfectly. But if we go and rub those out and press recalculate, that will go and actually fit that directly against the point cloud there now. So we can zoom and pan. Oh, I'll tell you what I'll do. I'll just insert that beam. You can see it's actually picked up the exact type of beam that we've got. And we'll just go and insert that one. I'm just again going to have to change my view command slightly just to see that steel there. But you can see there's that particular steel. If we go to the 3D view and go to orient to view, sections, and section 1, drop against here now, there's our inserted element. So we could just now, if we wanted to, extend that to fit. But what would be better, because obviously that could maybe skew on the axis, what would be better is if we go back into the command, fit structural element, and now go and actually insert that type of beam. So if I go and press start now and do a point here and a point here at the end, what that's going to do is it's actually going to best fit that steel beam at that length against the point cloud. Okay, and that's going to give us a better or a more accurately fitted beam. Okay, so you can see there's that beam fitted against the point cloud. I can do the same with columns, and then I can use my align structural elements tool to join all of those together. Okay, again, if anybody wants to see more of this, there's plenty more that we've got on YouTube and things to look at. So I'm just going to go and drop into the PowerPoint one more time, guys. There are a couple of other features we've got in terms of Toposurface creation and construction aids. Again, I haven't got any more time to go into those. We've got about 5 minutes left, so I'll hand over to Jack in a second. But we have got some good tools for creating construction aids, so planes. If anybody wants to do mass modeling of a roof structure, we've got some really good tools for creating planes and intersection lines. Similarly, we can use the point cloud for topo surfaces really well by using some of those heat mapping tools and exporting the results as polylines, creating a topo surface, so we can create topo surfaces from those point clouds themselves. Okay, so Sorry, it was a little bit rushed at the end there, guys, but just going to move on to this slide. I'm going to hand back over to Jack. So, Jack, I'm just going to mute my microphone to allow you to speak.
Hi, Chris. Good demo. Apparently, my voice isn't the best, probably because my internet isn't very quick. So, actually, Chris, it might be best if you wrap this up, but also we'll do the poll. There's 2 questions, one in chat and one in the Q&A that I'll draw your attention to as well. So I'll mute back off just so it's a bit clearer for everybody to hear what you can say. Okay, so check the questions and I'll do the poll in a minute.
Yeah, I can't get to the questions from my end, Jack, 'cause I'm just as presenter. But anyway, we've got free trials available. Like I said, if anybody wants to try this, just go to our download page in the FARO website. You can download this and you can have a 14-day trial, absolutely no problem. Try out and see how you get on. Okay. Let's click on that. Just to let you know, guys, we've got some upcoming events if anybody's interested in seeing this live. We do have a FARO Construction Day. We weren't specifically going to look at PointSense then, but we have got some great tech on show there, such as the Tracer M for laser projection, some AR and VR tech, which is really, really good stuff. And our next big event, I would say, we're going to be at is the Geo Business at the Business Design Centre. If anybody wants to drop by the stand, see this live, feel free. And we have also got a class at Autodesk University. Now, places to this are limited to 45. Obviously, you'll need an AU London ticket to come to this, but we have got an hour and a half hands-on lab where we're going to run through this and you can get up to speed with these tools. So if anybody wants to come to that, that's absolutely great. So thank you everybody for watching. I'm sorry, Jack, I can't get to the polls from my end here, so I might just have to leave it there. I'll mute my microphone back off, but thank you everybody for watching.
Okay, Chris. Yeah, I've just turned on this poll. So before we wrap up, if everybody could press a button on the last poll, hopefully this last hour has been well worth your time, and maybe we can do some more. So just to run this one, just see if you enjoyed and think this software is something of use, because hopefully that should answer some questions. Been a couple of questions on Q&A and chat. They've all been answered. Last one by Karim and Eamon. I'll get some confirmation of Chris to have a look at this separately, and we'll come back to you directly. Okay. Like I say, this session has all been recorded. We'll send links out, the slide deck. You can get a trial off our website of PointSense for Revit and try it out yourself. Obviously, use this video as a little bit of training, just to remind you of some of the steps that have been taken to pull this off. There's also YouTube channel with Chris's content, but also other webcasts around PointSense for Revit and our other products. So lots of good things to follow up with if you want to do more. But with that, thank you very much for everybody's attendance today. We've had a real good turnout today, so really grateful of that as it come near some time off for everybody for Easter. So thank you very much and enjoy the rest of your day. And I will now end the recording